I'm Thomas Mellgren. I'm the product manager for NCS that Carl has so nicely described here. I have a background in networking, both as a consultant, but also at the large Scandinavian ISP. I'm also a CCIE since 2007. So, demo time. I will switch out of PowerPoint for the demo, which is... So, as Carl... Here we go. So as Carl described, we have a variety of different northbound APIs or northbound interfaces. I will show a couple of different of them. I will use the CLI to start with, and then we'll switch over to the web UI, both because they all have different advantages, but also to show that how we actually configure what northbound interface we actually use towards NCS doesn't matter. It's just a matter of preference. Since we are humans here, we would use the CLI or the web UI. If we were machines, we would most likely use or REST or a programmatic API. So this is the I will start out with the Juniper style CLI of NCS. We have a kind of brand empty started NCS here. So I will start off by showing. So this is what it looks like before we have actually talked to the network. We have a number of devices configured in NCS. The only thing that we have here is information about how do we talk to the devices. We don't have anything other than that. We have an understanding of what kind of network element driver and what equipment we are going to talk about or talk to, and what address and how we will talk to it. Nothing else to that. So what we start off with is tell NCS to sync from the network, read the configuration from the network. And one big thing here is that since we have the actual configuration of the devices that we talk to described in Yang, it means that we don't just read text files and store that. We actually parse the configuration, understand it, and store it in a structured way in NCS, which is a huge thing, and I will kind of get back to why that is huge. So let's do that. So we'll tell NCS sync from the network. So we have, and I will show that a bit later, we have a big kind of demo network here that I'm syncing from with a variety of different boxes and vendors. But for now, let's leave that. Okay, so let's look at the configuration again. Right now we have actually read stuff here. We have, this is a Cisco iOS based router. We actually have interfaces, some stuff that is on the box. We also have a Juniper device here, and we have some configuration in that we have just synced from the network. So we are in sync with the network, and we are ready to do stuff.
Do you want to share?
You lost them? Nah, they're okay. It's okay for me. So I can use my arms to wave here as well. Yeah. So we will start off by kind of working with the device part, the lower part of NCS, to start off with just manipulating devices or a range of devices using NCS, and then we'll take the step up and look at the services and how we can use that. So let's start off with something simple here. Let's set the IP domain name. For a range of devices. I have a number of CE devices here, so I will say that, okay, let's set the IP domain name. And the commands that we have here is, of course, rendered from the data models that we have that describe the configuration. If you are familiar with Cisco configuration, it resembles the stuff that you actually configure on a Cisco router. Okay, let's do that. Let's look at what that actually translated to. Okay, this is, at this stage, we haven't sent anything to the network, obviously. So these are the kind of the normalized view of the change set here. Okay, so we will provide set the domain name for a number of different devices. The range expression I wrote there is translated to this. If we would actually send this to the network, what would happen? What would we send? And now we actually look at the actual commands that would be sent. Okay. Now we actually see the resemblance or understand that this is a Cisco box, and this is the command that would actually be sent to the network.
I have a quick question here.
Sure.
We were talking about abstraction layers with firewalls and multi-vendors and that kind of stuff. So we just did this all over Cisco. If that device group that you were using happened to be Juniper and Arista and everything else, would this output look different? Would it adjust on the fly to send a different output so it adjusts to those individual components?
Right, I can show that. So for this, what we just did here, we specified the number of devices that were from the same vendor. Okay. We could also do, and I can show that, use a template that has the corresponding commands for different vendors. Okay. But again, we are not up in the kind of the abstracted view of things yet. We are working with the devices. So we will look at a layer 3 VPN service in a couple of minutes here, and then you will see the kind of the abstracted view. But I can show you the device template as well.
I'm just curious.
Yep, sure. And I'll be happy to show it. So okay, so let's actually send it to the network. Okay, the boxes are configured. Now we can, of course, regret what we did and roll back a configuration from the network. Again, let's look at what we would do then. Oh, the difference from I loaded the rollback file. We would now remove the domain name. So let's look at what we would send to the network again. Yeah, we would send the command to reverse that change.
Right there.
Now, how are you actually achieving that result? Are you SSHing or telnetting to these devices? Is it SNMP? Is it netcon? Like
for this specific
actual mechanism to go actually add that command to the router?
Good question, and we will dive into a lot of details in that. Okay. But to kind of briefly, it depends. For this, these are all Cisco iOS-based devices. Then we use an SSH session and a CLI based. If it would have been a Juniper device, we would have talked netconf.
And what level of parallelism are you doing that in then, right? So if you had 1,000 devices to do this, like are you doing 1,000 parallel threads, or is it like a blocking expect script running on each one?
There's parallelism, perhaps not all at the same time, because that would performance-wise not be smart move, but.
So that is actually a huge question. It's a pretty big one. So let's just say that there's a lot of work gone into that. And parallelism is great unless you want transactions, right? Because there's going to be phase boundaries or step boundaries in two-phase commits. Sure. So we can parallelize the prepare and the commit and the persist. Let me tell you, we're doing this with tens of things. Doing this with 25,000 or more, that's when it becomes tricky. But it's parallelism.
Sure, because if the 24,000th one fails, right, you've got to roll back.
Exactly, and so it depends on the protocol, and it depends on what you want, right? If you want strong two-phase commits, then you can only allow parallelism in the 3 phases. If you don't care about transactions, you can parallelize everything, but your error situations and your fault domain will be very complicated and strange. Right. But out of the box, well, just trying to hand over to you. Out of the box, this is strong two-phase commits, so we parallelize for the phases.
Okay.
Does that make sense?
I think so.
Okay, good.
And I think we will show a number of different scenarios here. I think we will kind of tie into this discussion. I will just briefly show the device templates if we would have done something for multi-vendor stuff, and then we'll go to the services here as well.
Could I ask a quick question on the rollback? You did a rollback 0, right?
Right.
Now on a Juniper, having done the commit, if it was a Junos device, you'd normally do a rollback 1, because rollback 0 is now your current config. So I'm just trying to understand, it's kind of Junos alike, but then that seems to go in a different direction.
Right, so it's Juniper-like in the sense of a syntax, but there might be certainly differences. For us, your rollback 0 is the most recent change.
Do you use the Juniper rollback function?
Switch CLI?
No, or negate the commands?
The reason it is the way it is that in Juniper, they keep the entire configuration in rollback 0, right? Whereas we have configuration for 20,000 devices. So we only keep the configuration delta, which means that only the rollback files will only have a delta. So applying a rollback means applying a delta or undoing the last change or the number of last changes.
It also suggests, I mean, for a lot of configuration changes, I don't know, changing an ARP timeout, for example, to make that go away, you can't say no. You have to set it back to the correct value that is the default.
Yeah,
absolutely. Yeah.
And I mean, per version, you must know all these things. That's the device template, or I see.
That's part of the model, and this is the thing. This is why this model-driven approach is vastly different from templates, and hopefully we will capture some of these things. Templates are largely fire and forget and doesn't understand state. With models, you can actually look at transaction rollbacks, including the value space, and compute the diff, and which Johan will go into obscene details about. You can compute the diff backwards. And you're very right that most of the rollbacks, unless, first thing you show in a demo, for a Cisco CLI, you cannot even use textual tools to produce the rollback because it's not rich enough. The textual representation coming out of the router is not enough for you to compute the backward path. Right. There's ordering. In some places, and people with a big CCIE background probably knows a couple of examples where you have to go a very roundabout way, in the configuration command space to get back to where you were. And again, for that, you need rich semantic models, and we use Yang for that, so we can do a general, here's one version, here's another version, for any one version and another version, compute the order set of commands that would take us from this one to this one, which took a while to solve. Yeah.
Wow. So if the IP domain name had been configured as something else prior to changing it to telf.com, and you did the rollback, it would change it back to what it was configured to prior, not just doing a no to remove the command.
Right. Yes. So since we always have the understanding of the configuration in the network, we can always know how to get back to the previous state.
At any point in time backwards.
Right.
How do you handle devices that are offline?
Good question. I will show that in a couple of minutes. But I will certainly show that. Just to tie into your question there, what would happen if we had a number of devices from different vendors? We have, in this case, we have a small template that was set as an MP community for a Junos box, an iOS XR-based box, or an iOS box. And then we can apply that, and the NCS will figure out what commands to send depending on what device it will talk to.
Do you have any, and this may be kind of related to this, the templating as well, do you have any awareness of the code release that's running on the device? Because obviously features appear in certain revisions of code.
Defaults change.
Defaults change, which is a huge one, right? And so even just to say Junos is not really enough, because there's the switching version of Junos. Sorry, it's all one Junos, isn't it? But there's the switching version of Junos and bridge. Right. Then there's the bridge domains MX style version, and you're trying to do the same thing two completely different ways, right? So I'm curious how you manage that.
So we have strong versioning. When you say that, it depends on the protocol. So for netconf, you actually have versions on the modules, and a Junos can be very many modules. For CLI space, the version of the module is actually usually the name of the version of the iOS, right? There's a couple of things that can happen across releases, and of course this is where we hear war stories. Changing defaults is probably the most horrific one. No system in the world can programmatically infer that, right? So you need subject matter expertise when you roll into supporting that version. So no software can do that. Then there's two major classes of change. One is the minute small things, some sort of an option change from integer 32 to integer 64. You don't have to upgrade for that, actually, because you can prove that your current situation allows for the entire value space for that option. But so you don't have to upgrade if you don't want to, unless you want to use the upper 32 bits. And then there's a stranger one, which is actually changing the semantics or the structure of the CLI. Again, with netconf and model-driven stuff, you will get that out of the router. It will give you the entire value space in a structured format. But for things where you don't have the model, the CLI, you have to have a CCIE or someone that really loves that can describe to the system what the changes are when you find a new version. Now, the point of the system is to make that really straightforward. So what you do is you literally edit the Yang file, you reload the package, usually done in 30 minutes, unless it's vast changes in the model. So that's kind of the three big ones.
And I guess that's the support question, right, is from the perspective of a customer, I buy this thing and off the shelf it does a certain amount, and then as my software gets upgraded, how much do I, Mr. Customer, have to figure out the differences versus I just download an update from you guys because you did the hard work, you looked at the release notes and saw the default changed, and you did that for me.
Yeah.
Because as a customer, that's what I want, personally.
Right. I'd say that that's one of the two really tough things with this. And the economy around the adapters, especially for things that are not programmatic or model-driven, right? Because again, if you can get a full formal description of the router, we can synthesize that new driver and just add support for it, right? May impact your services, may not. The other end of the extreme is the model-free or model-less environments, which is things like the Cisco-style CLI. And then you have to find someone willing to do it. We'll be happy to do it. Some customers want to do it. But what we can do is capture the fact that this is a version we haven't seen before. It is a type of adapter that's not model-driven. Be careful, because who knows what's changed. See what I mean?
Yes, and kind of what I'm hearing is if you have something that's not already there, you either have to do it yourself, or when you say you're willing to do it, I'm assuming you're not a charity, so we can pay you to do it, is kind of where we're going with that.
Or use your third party. There's a growing couple of companies that will be happy to do it for you. And while you do this, please bend the arm of those vendors and say, we can't have that over time. Because again, what we're trying to do is to make, this is a fundamentally intractable problem. It's using a human-to-machine interface as a machine-to-machine interface. The underlying problem can't be fixed. We need to move out of it. The entire idea here is to make that, fixing that as straightforward and as fast as possible. And what you can imagine that the customers are testing us on this, saying, here's a new version, how fast can we do this, or how fast can you do this? And since it's model-driven, it's usually a couple of hours, rather than going back and saying, when's the support for the next version, Arista? See what I mean?
Yeah, and this talks to a problem that I've been talking about with colleagues of getting to that nirvana of some sorts where you can represent any configuration in an abstracted form, so that I can say, I want to configure X, Y, and Z, and push it out to 6 different models of device at the same time, not needing to worry about what's happening under the hood. I'm giving it a generic configuration, almost puppet style, I guess, right? But give it a generic configuration and let it push out. And that also then allows us to pull the configurations and pull them back into that abstraction so that we have one consistent database. And that again then moves into migration paths and everything else.
Back to the demo, because that's what we're showing.
Okay, good.
Let's jump to that. It will be more fun. Okay, so that was kind of an introduction or small bits and pieces of the kind of the device layer. Let's look at the services, because that's where things get exciting. So I will switch over to our web UI here. The service we have what we're going to show here is a layer 3 VPN service. The demo network that we have is kind of a typical service provider MPLS VPN. A number of P routers that are iOS XR based, for example, a 9K. We have a number of PE routers. 3 of them are iOS XR based, and 1 is a Juniper box. And then we have a number of Cisco iOS based routers as C routers here, just to show you that we can talk to different vendors with different protocols. And all of the boxes are simulated on my laptop here. And I can show you that, and I will show you that. We could just as well configure this in the CLI, of course. In the web UI, we of course have the ability to make kind of nice little custom widgets like this with a map to make things slightly more user friendly. Included in my little service here, I've created a very, very simple topology, which is basically just a list of connections. And I guess this is something I've done for this service. It's only a list of connections saying that C router 0 is connected to P router 0. These are the interfaces on each side, and this is the link network. Only the stuff in the topology that I need for this service. And I will get back to why I wanted to kind of break it out and not supply it as a parameter. But the map here is derived and drawn from that simple topology. So let's create a VPN. All the parameters that are right here, all the stuff that I input to NCS are described in a YANG model. So this is the web UI representation of the service YANG model that describes my layer 3 VPN. No hard-coded stuff. If I would add another global parameter here in the YANG model, it would turn up in the web UI.
Volvo. Of course. Go ahead.
Volvo. I'm Swedish. Come on.
You're Chinese.
Yeah, Swedish Chinese. So let's give the VPN a name and an AES number. Should we use Klingon?
Klingonberry.
Doesn't matter.
Klingonberry Volvo. Klingonberry.
It's a very good name for a VPN. Okay, we have added the kind of the global parameters. Let's pick the endpoints in the VPN here. Office 1. Let's give it a local IP network and a bandwidth. And also let's pick one from the connected to the Juniper P router here, just to make things exciting. Okay, so what we configured is the global parameters and two C routers. Again, at this state, we haven't actually sent anything to the network. We will only configure the parameters defined in the YANG model for the service. So let's look at what would happen if we would actually send this to the network. So now we get to see the actual protocol representation, the exact commands or protocols that would be sent to the network. This is a C router, so we would talk Cisco CLI, of course. We create our famous Klingonberry policy map with the excellent. So you can see that the parameters taken from the service that we configured are now put in the context of device-specific configuration. We have our two C routers. We have the Cisco iOS XRP router here. And of course, here is our Juniper router, and towards the Juniper router we talk netconf. So this is the actual netconf output.
And these are one of the features that we were pointed out that would be useful, right? Because again, people don't want things to happen in a black box, right? They would like to see. It's also very useful when you develop these things, because you show this to the subject matter experts for each of the vendors and work with them until you get the right output, right? So it's a very important thing when you develop the service mapping.
So it looks good. Let's roll it out. Let's send it to the network. And again, as we talked to, we like transaction. Doing things in an atomic transaction is of course extremely important if you want to be able to automate this in a true fashion. So when we actually configure this, the C routers and the P routers will either all be configured or everything will be rolled back if something happens, or if one of them would be down or we couldn't connect to it. And I will also show that in a couple of minutes here. So let's actually roll it out. Great. Network is configured. One of the things that NCS is extremely smart about, and again, this is not, again, since we don't just send chunks of text, we have both the service and the device and the configuration in the network represented in a structured way in NCS. We know everything. We have a data model representation of it. We can always figure out a minimal diff to send to the network. So if we perform changes to our VPN here, we will not send chunks of config. We will figure out the minimal thing to send to the network. So let's illustrate that by changing the. Oh, we have a small resize. Let's change the AES number here. What would happen if I sent that to the network? Well, for the C routers, I would tear down and remove the BGP process and create a new one with the correct AES number. On the iOS XR-based P router, I actually based the route target on the AES number, so that would be removed and a new one would be created. I updated the remote AES statement. And for the Juniper router, I do the same. So we only send the needed commands or the needed protocols to actually perform the change.
So real quick, before we get too far off this is really cool. In our environment, what we're doing is scaling out pretty quickly what we do. And along with that, there becomes all the other components of monitoring, importing Inagios, setting up DNS, all that stuff. You guys are really powerful on the network side. Is there any type of hook to systems level structures that you can do that once we set up these templates, once we do all this, when we press play, it auto-fills all the other things, and now we have a monitored node in our environment as well?
As I mentioned, this is never deployed standalone. These things come, the first week. So yes, there's a wide variety of APIs and hooks and crannies. So you can tie that to the transaction where you actually do it if you need near real-time updates, or you can do it as a post-commit hook, Juniper people will call it. There's a variety of ways of doing.
Well, I know we could probably scrape your database and we could generate things off of that. I just didn't
but that is absolutely the typical scenario that we tie into inventory system or monitoring systems to actually work together since we do that.
See what I mean by that? So part of the transaction, I mean, we could literally, if we don't make an update to that, maybe we just say that's a catastrophic failure because that will wreck other things, so roll back. So that could be part of the criteria for closing the transaction if you want, right? This is the thing, it's always different. So it's always the kind of the turnaround is to say, what is it that you want to do? And we'll show you how to do that.
And all this stuff is totally exposed to an API, so you could do a custom portal. So you had, even down to the point you could have a sales team saying this client wants to do this. They put stuff in and it comes down through an authorization level. We commit it and it goes.
Absolutely. And I mean, the end game for many of our customers is to not even have a salesperson, but have the customer do it. I want to change my VPN. I want to add an endpoint. I want to add firewalls, bandwidth.
Yeah, well, change the bandwidth on my endpoint here, and it will automatically be provisioned.
So how do you sanity check the configs that are being pushed to the device? A good example would be like if I have a route map in Cisco World and I reference an ACL, but I blow out the ACL, the route map still exists.
Right.
And it'll actually drop all the traffic.
So there's a number of different ways to do that. You can have a lot of kind of validation and constraints and policies saying that a VLAN needs to be unique across the network, or make sure that this ACL is present before you perform this change. When it comes to services like this, of course, it's when you design the service, it's a process where you sit down with the people that create the model and the subject matter experts, and to ensure that the actual config is correct. But there's certainly parts where you want to be able to add constraints and validation to ensure that, but then nothing erroneous can actually be sent to the network.
Right. So if we wanted to go in and change a granular setting within a service, we would be better off to address the model as a whole instead of changing the granular portion of that service, I guess.
No. So the service then will, of course, drives the change. And what you can do, and we have precious little time today. Of course, this is another half a day. Is that it's straightforward to, in various different layers, address policies and validation rules. All the way from actually including in the service models, you can say, you can only use VLANs in this span. Right. You can't reuse IP addresses, which is quite a big thing. Don't reuse IP addresses. Yeah. You can declare that in the service. We can actually catch it on the API and say the IP address that's coming in for this instance is actually used here, abort.
Okay.
And then what usually happens is that you get to the operations teams and they have this pink sheet of engineering rules. And we look at them and say, so actually some of these things can actually be moved onto NCS. If it's this part of the day, don't change that in that region.
Okay.
All these things can be caught up there. It depends on the nature of the requirements. Some of these things can't be programmed for. Right. You actually need a human for it because it's just, you can't formally describe it. But there's a huge variety of it.
But also a lot of the problems that I'm sure you guys see a lot, and in my past working at the service provider, the manual work that people by mistake remove the ACL before they attach it, you get by a lot of that by actually having services like this where you have well-defined configurations that will be sent to the network. You get the humans out of the loop for the day-to-day provision, and you kind of skip the human mistakes in that part.
And of course, an observation is that the way people start with this is not that they move the entire operations on top of it. They usually start with something, okay, we know L3 VPN provisioning very well. There's very little variety on how you do that. So why don't we start with that? See what I mean? So it's not a flag day thing. They usually introduce it very carefully. I know people have already mentioned trust issues on Twitter. That's of course the elephant in the room for us. Not only before we get people interested in this, but also when they start using it.
And of course, one of the key drivers of automation in the network is reducing human error, right?
Absolutely.
But the corollary to that is if you're providing automation, part of the idea there is that you're pushing the ability to add this functionality down to lower skilled resources, maybe even end customers in some cases. So it's really important to know that the system that's deploying those changes can be as careful as a top level network engineer who's not making a human error mistake would be doing, right?
Yeah,
I mean, because you don't have somebody necessarily then that top level architect kind of guy checking over what's happening. So you need to know that that's going to go right.
Well, another thing, I mean, like if you could say, regardless of the size of your change, let's say you have a change that you want to implement network wide, and you can chunk it up into like reasonably sized portions. I'm thinking like change management, for instance. If you wanted to do one part and then do the human check, I mean, that would almost be the job of like a workflow engine. I'm not sure that's something you guys want to get involved with, but you see what I'm saying? You could chunk it up into different portions, and then at a certain point say, are we good? Verify. Now let's move on to the next step.
Yeah, I mean, we have customers that takes the output of that dry run and puts it to the side and cancel that transaction and have someone look at it, re-import it, and off you go again. Cool. Put that in Subversion or whatever. Whatever floats your ticketing and workflow boat is fine. Take it out and bring it in later, because to the point, and this is important, we will never be that long workflow with steps like that. That's what people use. That's what people build or already have on top of us.
Yeah.
We're here when you're ready to do the transaction.
Right.
The short-lived transactions with the abstraction layer.
Yeah.
Well, it's already been brought up on Twitter too that this doesn't replace the engineer, and I think that's really cool that you guys are approaching this from that perspective, because tools like this free up the engineering team to actually do the things I need them to do, as opposed to sitting there and just munging through data and configs, scripts, and all that crap.
Yeah, adding VRFs gets old after a while. So after number 1000, you know it.
And it's an important point actually, because this thing usually lands with the networking team, right? Not with the IT people. It can be a nice, kind of almost protection barrier. Here's the contract language, Yang, right? Here's the REST API, netconf, Java, whatever. Here's what we promise to deliver if you guys in the IT domain or in the OSS domain wants to get things out of the network. So it becomes a formal handover interface.
So the kind of, go ahead.
Sorry, you explained about rolling back the commit if a device couldn't be contacted or whatever.
Right.
What about the alternative case, updating the domain name or something, where you want to push that everywhere, some devices are down? How do we catch up with those?
Yeah, so again, out of the box, we're very, hardline transactions, right? But you're right, we have customers that want to change the NTP server of 20,000 boxes. Doesn't matter.
A third of my network's offline.
Exactly, and 2 to 3% of your network will be offline if you have a big one.
Yep.
End of story, right? And what you can do then is something called commit queues. So it will make the transaction engine more lax, and it will queue these things and retry.
Gotcha.
See what I mean? But that will leave that kind of transaction lingering, if you like, because usually the application wants to know when we're all done, right? Independent of whether it happens inside of a second, 10 seconds, or 2 days. Again, it's called commit queues. There's a whole lot of things. Again, we have short time here, but we can queue things up and wait for it, and we can then fail that transaction, but leave things in the network if we want to.
I've got routers I haven't heard from for a year, and
they're doing fine. They tell me.
I mean, they're shut down. They're in a police car that's broken,
right.
And so I can't update it.
Right.
And if there was something that would persist and try, it's very useful.
Now, how do you handle the transitory state that happens during a large? So let's say you're rolling out a change to a large number of devices, right? Yep. And you're doing it in a relatively serial manner to try to confirm that transactional nature, right? And the N-1 or N-5 device fails, and you've got to roll everything back. You potentially have had a long time where you've had kind of a transitional state where the network is behaving differently. I'm not thinking simple things like NTP servers, but I'm thinking a route map or something that's applying real policy, a QoS change or something.
And I think that what Carl said, the underlying problem will never go away. If you have a box that doesn't natively have transactions like Cisco IS, the config will bite directly. There's no way to get around that. But certainly we do also do the transaction in different phases. We try to connect to them first. If we see that, well, one of them can't be connected to, we don't really actually start rolling out changes. But you could actually get to a state like that if something fails in the configuration at the time. But that's the beauty of devices that actually support transactions.
At the beginning of your presentation, you had how to contact the devices, but nothing else. No configs. You just knew that there was routers out there, right?
Right.
do you categorize them based on some rules then, so that you can figure out that that's PE and that's a P router and that kind of thing, or?
We can set kind of logical groups or device groups, saying that okay, these are the number of these devices are in the PE group, and they can be of different hierarchies. So you can both have
based on their names or flexible criteria. If I see this bit of config in such and type of router,
it's up to you how you do it, right?
Because it's so different. Right. It's so different.
I'm curious as to, as you've deployed these, if you have any metrics on how many, so to kind of go back to what Ed was saying about sanity checking the network and things like that, how many times have you deployed these that that the deployment has identified some sort of unknown misconfiguration in the network? I mean, because it seems like there would be, a chance to get pretty good metrics out of that, right? Like you take it to Deutsche Telekom or whatever, and they put it in, they go, oh, we found all of this random stuff that we had no idea was misconfigured out there. Is there any, do you have any kind of metrics?
Yes, so that's a big question. There's two things in here. First of all, yes, so we almost always get deployed in brownfield networks, right? Existing networks that's been tugging along for many years.
Right.
And in order to actually find out whether they're misconfigured, you have to do something that can be loosely described as service discovery. You have to infer from the configuration in these boxes what they're actually doing, which is non-trivial. Because actually, the service provisioning in general is destructive downstack, so you lose information going into the actual configuration. And if NCS is brought up on a brownfield network where that process is already done, we can provide the building blocks to figure out what these configurations mean, but you have to tie it together on top. But what we can definitely say is that they're all out of sync with what people expect.
That's the answer that I was looking
for.
So
it's a boring metric, because I would love to be able to tell you to the degree of 25% of all lines, but we're not just not there yet. Right. In terms of service discovery and being able to say, actually, this is the negative delta towards what you need. We haven't gone that far yet, but we can definitely say that they're all out of sync. And one of the things that we should just try and get on with the demo.
Yeah, we might. But one of the really good things is that when you're actually gone through that process, there's a lot of tools, and I will show that as well, to actually, NCS can say, we're out of the sync with the network, something has happened. Right. And just being able to identify the trash config that you have.
Well, that's kind of what I'm getting at here. It's a forcing function to go through and sort of fine-grain look through your config that everybody says they need to do on every network they've ever run,
right.
And nobody ever does.
Yeah, and you can certainly, once you've deployed this and gone through that process, configuration that is not actually, VPN configuration that's not actually tied to service instance, that is probably something you don't want in your network, and you can, start analyzing that.
Yep.
Demo. So demo. We changed, let's see where we were. We changed the AS number here. Again, we're good at figuring out the minimal diff, so we will actually send that to network. And again, we're good at rolling back, so let's roll that back. One thing that is interesting here is that the rollback file that we see here has nothing to do. It doesn't show any device layer or device-specific configuration. It shows the actual the service configuration here. We want to go back to that value, and the reason for that is that, okay, we want to roll back to this state, but the network might have changed. So we always need to compute the accurate configuration changes that needs to be sent to the network to go from the current state in the network to this. So we never save the actual the device configuration that is the computer from this. We always perform that so we can look at what is in the network now. So let's load that. Look at it again. Of course, it's the same process. We remove the old AS number and add the new one.
Does TLF expect that there's an out-of-band network that is being leveraged to push configurations and so on?
Again, it depends on the scenario. We have both scenarios where NCS is the complete authority of configuration changes in the network. But there's, of course, if you have a huge network, there will always be scenarios where you have other systems or out-of-band changes, and you can say that is okay. Certainly, you will end up, either if you have NCS or whatever you use to configure a network, if you have different systems configuring the same part of the configuration, you will end up with problems. So as long as you have kind of disjunct part of the configuration, you're good.
And yes, we have customers asking for rolling back over modem. See what I mean?
Well, there's the power here to really screw yourself up, on
Yes,
particularly in a large network where you
Yes.
roll out a big change and all of a sudden your management station can no longer talk to the
Exactly.
network because of a change that just happened.
Yeah.
So how do you,
So I mean, there's again, this is so network specific. So the subject network experts have to tell them, and we see a wide variety of strategies. Number one, if it's something that has an ambitious netconf with a two-phase commit, you should be just by losing the administrative session, the Junos will actually roll back, and that's supposed to fix it, right?
Right.
But rarely do you have such a clean-cut network. So, and then it just depends. And like I said, we do have customers that says, actually, can we do it so that if we fail on the management IP address, we try the modem to it or instead.
Right, or connect to the same device through a terminal server and,
Right.
and do stuff. So that's.
And can you do that?
Yes.
Okay, I'm just checking. I know you said you had customers asking. I wasn't sure if you,
Yes,
if you
we
delivered
can.
on that.
So for
In
anyone
my
single
Swedish
device,
mind, that means that yes, we do it.
Yeah, we can do. And
this fails, then go on the list.
right, so we can both have multiple IP addresses, but also
Yeah.
very custom scenarios where you want to go through exotic modem connections or whatever. Okay, let's briefly switch back to the CLI and actually look at the stuff here. So this is if you look at now I'm using the Cisco style CLI. I'm more fluent in Cisco. So now I look at the configuration representation of the stuff that we just provisioned in the web UI. So this is the actual config. Of course, if you are a Juniper guy, you can just switch and look at it in Juniper style instead. So you pick your poison.
It's kind of huge, really.
Yeah, we have customers that mainly use it as a power tool, where they want their network engineers are used to Cisco Juniper, and they want to use that for all their vendors, all the 12 vendors, and they want to have a common.
Yeah, I mean, not just that, but I mean, sometimes you get in a case where maybe you're interviewing a candidate and they're a really good engineer, but they are just they grew up on the other platform, right?
Yeah. So
that's kind of huge. That I can configure the network with an iOS CLI, and you can configure the network with a Juno CLI.
Yep.
We didn't
the same network.
We didn't understand the impact of that, but my observation from the customers we have, I wholeheartedly agree.
Yeah. I think that is huge.
That's huge.
I'm also very interested. I mean, you said you had support for things like Brocade and Alcatel-Lucent. I mean, Alcatel-Lucent on the 7750 series is a completely different CLI than anything else out there. If you can abstract that out to Junos,
here we look at
monumental.
Exactly. Yes. And it, again, here you look at the data model representation. So it might as well be something completely weird that talks SOAP or whatever, and you will see the data model representation here in a.
And of course, you can do the same things with REST, right? Again, this is just ways of getting into the database, manipulating that data, and when you're done, you push it to the network.
Yeah. Right. Let me switch back to. So let's actually test the transactional behavior and see what will happen if one of the boxes is down and we try to provision a VPN. Okay, so I loaded a new VPN. We haven't sent anything to the network. Well, you will recognize the configuration here. A number of different endpoints, a new AS number. Let's switch over and actually say that C router 3 here, the top one is, unplug that and see what happens if we try to commit it. Okay, so C router 3 is now down. So now I did a commit, and you can see all the phases that we're going through, but we will end up with seeing that, okay, we weren't able to connect to C router 3, roll everything back, or stop the transaction. So nothing will be sent to the network. And let's start it again.
Is it actually trying to connect to every device before it pushes any configs out, or is I couldn't quite tell the sequence there, or is it that it connects to all of them at the same time, discovers the one's not responding, and then backs the rest out? It's that.
That is the order of business here, is connect to all of them, because, I mean, again, there are many classes of failures, right? One of them is not available.
Right.
Others could be fail midstream. In the middle of the command set you send, something happens here, right? Which is a different failure case.
But the actual connections here are done in parallel, of course.
Yes.
We're not doing it sequentially. So we're doing it in parallel. But we'll see one of them fails before we go to the next.
So that's what I mentioned by parallelism in each step. So we parallel connect, check that everybody's there, and we configure parallelly, check that it bit, and then we persist in parallel. But we can't really do everything in parallel, because then we would lose the transaction aspects of these things.
Okay, thank you.
Okay, so we brought out the C router again. And we're done. And now we can see that we have two service instances here. We can, of course, in the CLI also look at the actual what did this service modify in the network. When I provisioned this, what actual changes was done in the network here. You can track that. And since we have the structure view of both the device configuration and the service configuration, we always have the relations. We know exactly what configuration on the devices are related to what service instances. So we can look at the configuration on this interface on the P router, what service instances are using that. If we would bring this interface down, what customers in our VPN in our network would be affected, which is huge.
Now, do you, in the case of something like iOS, right, where you know there's not a real good mechanism besides manual review to check that what you configured is really what took, right? I mean, does your configuration do any sort of a validation pass? Like, I'm thinking of something like, you know, you've got a redistribution route map on an OSPF command, right? If you just know out that entire line because you want to remove, you know, the redistribution, right? That doesn't remove the redistribution, it removes the route map that's applying the redistribution, now you're redistributing in an unlimited fashion, right? Like, there's a lot of gotchas like that in iOS and probably in other platforms too. So that's one of those things, like, you know, back to the CCIE, right? Verify, verify, verify. Like, how do you verify that when you put the command in, what you ended up with is what you kind of had templated for what that change should look like?
And that is kind of part of the development of the data model for that device. That when you have quirks like that in commands, you need to create the data model to actually represent that to ensure that we.
So you guys just have a whole lot of brains working on that to make sure that that all.
Yeah, it is well easier than you might think, but yes, well, there's a process, of course, to get into that. But there's a lot of tools and kind of annotations to do exactly that, to ensure that, okay, if you want to move that, you need to actually provide all the parameters here. Or not.
So what you're saying is test something in the lab before you roll it out.
That's a good one.
Yeah,
that's a good one. Yes, I'll subscribe to that.
That's crazy.
That's just good practice.
It's a weird thought, but we support it. That you actually.
But at the same time, I think your guys' platform probably has enough flexibility that you guys could build in some landmine testing features. And so, I mean, we talked about AAA auth into these platforms and what we're going to do in validation. And I think we get too wrapped up in automation systems taking over, you know, having kind of Skynet, and that's not the point here.
Right.
I think, and you guys can tell me if you're wrong, but I think there's some really good ways to build intelligence into this through engineers looking at this and to not, you know, step on your toes. I was just going to respond to Terran. He said, you know, I think out of band's almost necessary.
Right.
I think if there's aspects of a network that don't have out of band, it should be a certain process group that says you're trying to apply something that's probably going to do bad things. That's intelligence that's going to be driven by the engineers building a process into your platform and not just assuming your platform is going to save the day.
Yeah, this is exactly why the engineer is still absolutely required.
Absolutely.
Because there's nobody that can tell, there's no system that can tell you this part of the network needs to be configured this way, and this part needs to be configured. You need to be aware of those things.
Topologi ännu en.
Okay, do that. Yeah. So demos drive questions. Good memo for next year.
That's good. Om vi vill testa checksync.
Sure. Go.
So let's actually test one more thing here so let's log into to our CE3 here that we provisioned. You can see that we have some BGP and policy maps, etc. Let me be a naughty network engineer and do out-of-band changes and actually destroy the config here. Let's just completely remove BGP here. And that was part of the Ford VPN here. So now I want to change the AS number for this VPN as an example. Again, I can of course look at what that would mean if I would send it to network, just like we did before. But this time, if I am to actually send it to network, we would say no, we can't provision this. NCS is out of sync with the network. Someone has done something. So we can see that, okay, device CE3 is out of sync here. What has happened? Let's look at the, oh, sorry. Well, we can see that this is the difference from NCS view of the network with what we actually have out in the network. We're missing the BGP configuration. If this is a good change, that's something that we need to actually make NCS understand, okay, then we can say that, okay, sync the configuration from the device again, make us trust this. Or in this case, someone has done something bad, we'll say that, okay, just push out the configuration for this CE router again. We push that out, and then we're able to provision that again. So I want to show one last thing before we move on. Here we have our alarm about failure earlier, and I wanted to show why I had a little small topology stuff on the side here and show a use case that I think everyone that's worked with large enterprises service providers has been. Imagine a use case where you want to migrate VPN customers from one P routers to another, or you want to actually change hardware perhaps. You want to add a new vendor and automatically migrate the VPNs that you have there. Or you just want to change the structure of your network or load balance that. And in this case, the P routers that are configured is completely derived from my little topology here. So let's just say that, okay, CE router 5 should now be connected to PE3 instead. Okay, I haven't done anything to the network here. I just updated my little topology. The map was redrawn. I can see that, okay, it's connected here again. Then I can tell my service instance there, okay, take all the VPNs and redeploy them to the network. And what would happen then? So let's redeploy our VPN here. So as you can see, for the CE router, I would just update the description of the connections there to reflect the correct. I would configure the new P router, the Cisco IS XR base that we moved to, and I would decommission the configuration on the Juniper box. And of course, this is a simple scenario where I just moved one customer, but take a large service providers where you have 5,000 VPN endpoints connected to P router. You have basically a one-liner to migrate that to a different P router using a different vendor, and you don't have to care about the configuration there.
Okay, so question here. I know we keep stepping all over you.
No, that's perfect. That's perfect.
So you've done this, and of course you're going to have your network management and all this stuff to kind of address that. Do you guys have any type of structure built into this to easily go back or run a test for connectivity as this stuff comes up within your platform? Not that It's fine. It's just curious.
There's many ways to do that, and that's you see that as a recurring theme, and the ideas on how to do this varies from let's do it as part of a transaction because burn-in tests. If we don't do that, we actually want to roll back the thing to say we have assurance systems that do that. So ping them when you're done, and we will be back and do it. So there's hooks and knobs and things around the whole thing. So
or you can create
depends on the culture of the team that takes this thing into production.
Or you can create a custom command for this service that, okay, well, our provision, you do a self-test that, well, you can write the stuff that actually do ping from endpoint to
So you
endpoint.
can do it from your platform, but back to your point, this doesn't happen in a vacuum. Your tool isn't used in a vacuum, it's used in an ecosystem of other tools. All right.
Always. So absolutely. I mean, you can do it, again, tightly integrated using our stuff or hand over to something else. Yeah.
So I've got 2 more questions just to really be a pain. For like iOS XR, I seem to recall has a sort of a commit functionality. Is that something that the NCS takes advantage of?
Yes.
What I saw up there, it's not clear whether it would be doing that.
Right.
It's just here's your config change.
No,
right?
certainly. If the underlying device has transactional behavior, we absolutely take. So for XR, yes.
Okay, so the other question was about the speed at which changes happen. I mean, what we're seeing here is tremendously fast. On the other hand, it's also locally hosted simulated devices, and I'm not sure if they're real devices or if they are literally simulations that accept commands. So how does what we're seeing in the demo compare with what you see in a typical network? When you hit save, here we're seeing like 2 seconds, and we're done. Right? I can barely get my SSH connection up in 2 seconds and exchange keys and stuff. So it's something not quite syncing with reality.
And that is a good point, and I think you can jump in. The big latency that we see is often setting up the SSH connection and actual network latency.
And also some of the vendors have, especially the bigger iron, they will take a couple of tenths of second to even the most minute configuration change. Nothing we can do about that. Yes, that latency will trickle up. If you want a synchronous API, many people do that, you'll have to sit and go twiddle, twiddle. We can do asynchronous and say, it worked, but check for alarms. See what I mean? Hand that over and say, we're going to do this in the background. Might not work actually, so check for alarms while you're doing this. But as I actually said in my slide, that's the #1 challenge we have in very large networks, is that the latency of some of these vendors to come back and just say that drives massive parallelism. I mean, we literally have to have thousands of parallel sessions going, just waiting for the routers and switches to respond.
That's not new to you guys.
No.
Anytime you look at a network management platform, I mean,
Right.
You get all this back pressure, and you end up with 40-minute polls of SNMP of your entire environment. You spin up polar and polar and polar. But
and I mean, the interesting thing for us now, having this other product that I mentioned briefly, is that we can help, and we do help some of these vendors to optimize the stack for this direction, not just this direction. And some of them really know this, and some of the service providers are telling them in no uncertain terms that this will change. We will not wait 30 seconds for a VPN command, going forward. That's just a non-starter.
And the trick, of course, is that being able to keep somewhat transactional integrity in a scenario like that, where you can actually, with the different latencies, still have the consistency of the network changes.
Yep.
Now, clearly, at some point, we would all like to get to this place where we see everything as a service, right? We're deploying things as a service. Right. Are you able to handle, like from the CLI, a change that affects only like one device or a couple devices? Or can you only use that to push devices to everything?
No, certainly you can go in here and say that, okay, let's create the VRF here. So I can use it as to do stuff in one device.
The point is you want to keep NCS synced with the device, with the device configs, right? You probably want NCS to be your single point of administration.
So you can use it as one device, or I can say here that, okay, let's add...
and you did a range before.
Right, so let's add this VRF to these devices.
Cool.
So yes, there's both services and device kind of layers to this. So again, extremely powerful tool if you to just redeploy all the VPNs, and it will kind of recalculate and compute all the changes that needs to be to the network. We looked at the output of that. Just configuring the new P router, decommissioning the old, and we can of course redeploy that. So the last thing I want to show, then I'll hand over to you on.
Fast.
Very fast. one thing that is extremely important for service providers is actually being able to decommission stuff from the network, actually delete. We have a customer that has moved on, or we don't want this VPN. And it's extremely important to be able to actually clean up the network.
Yeah.
So, and of course,
nobody deletes ACL entries anymore.
No, they don't. That's right.
Yeah, and at the service provider I worked with, I think we have more than one person just working full time, just cleaning out the trash in the
artifacts are a huge problem.
So again, for us, it's like any configuration change. We are very good at walking between states. So let's just remove it. We will just decommission the stuff that we have sent to the network here.
And if you go into that brownfield site, as we talked about before, and you get all your initial configs, the ability to do this is based on the fact that it's pulled everything up from multiple devices into an object.
Yes.
Is that part of that import process? Yes. It's smart enough to go, haha, I spot this for various. Okay, that's
yeah. Of course, you need to do somewhere kind of get the relation between the service instance and the actual
right. So you
yes,
have that good cleanup, which is fantastic.